Alright, so we're going to look at the distributive property today. Skipping over the check since we went over the homework. So today's learning targets are to use the distributive property to evaluate expressions and to use the distributive property to simplify expressions. And then we have our new vocabulary. So the first definition that we have is for the distributive property. Oops. Alright, so we have the distributive property here. And it just says this is how in algebra we get rid of parentheses. So if you have a value A sitting outside of a parenthesis and you have B and C hanging out on the inside, pretty much what A is going to do is it pops the parenthesis, kind of tears that fence down so that the A can play with both B and C, not just one or the other, but the A value hangs out with both. And so that's what distribution is. But questions? You want to write that down? Some note. Alright, so example 1, we're going to use it with addition. So we have Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. Use the distributive property to write and evaluate an expression that determines the total number of minutes Julio walks. So the first thing we need to do is we need to take that word problem and translate it into algebra. So we have Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. So how are we going to, yes?
Well, I figured you can do 7 plus 2.
Okay, well we want to set it up first. So do you want 7 and 2 together?
Yeah.
Alright, so, and that represents how far he walked, or how long he walks.
How long he walks.
For 1 day, right?
1 day. And then multiply that by 5.
And we want to multiply that whole thing by 5. So it tells us that we're to use the distributive property because in order of operations, we do parentheses. So let's, instead of adding the 7 and 2 together, we're going to distribute this 5. But does the 5 just get distributed to the first term? The second one too. The 5 is going to play in the yard with both 7 and 2. So when we do this, we have 5 times 7, which is
35.
And 5 times 2. 10. Alright, so now we're going to add these together. So 35 plus 10.
45.
So in 5 days, Julio walks for 45. What's my units? Minutes. Alright, questions on that one? That was. Alright, now one for you, another example if you want. Oh. Alright, so now I want you to try this one. So C is the correct answer. Alright, so now let's look at example 2, and this is using the distributive property to help with mental math. So we're going to use the distributive property to rewrite 12 times 82 and then evaluate. So we're going to use order of operations to kind of break this down so that it's easier. So they have 12 times 82, and another way of writing 12 is 10 plus 2, and then multiplying it by 82. And so if we distribute this, what's 10 times 82? If you, what's 2 times 10?
20.
20, and so you just added a 0 behind your 2, right?
Yeah.
So here we have 82 times 10, so we're just going to add a 0, so this would be 820. And then what's 2 times 82?
164.
So 164. So now, is this, we can add these together. I'm going to put my 164 down here so it's easier. So 0 plus 4 is 4. Alright, so breaking it down, it was much easier to do this way than to try to multiply that, right? Alright. So now let's try this one. Alright, so working this out, it looks like C is going to be our answer when we break it apart, and it is. Alright, so now example 3. We're going to rewrite 12 times the quantity y plus 3 using the distributive property, and then we're going to simplify. So here we have 12 hanging outside of our parenthesis. The 12 wants to play with both the y and 3, so we're going to use the distributive property to show that. Yep. Well, we don't have an equal sign, so we're just going to simplify, so we're just going to leave it. So we're going to have 12 times y plus 12 times 3, so we get that 12y plus 36. And then we're done. We're going to stop there until we're given further information to know what to do. Alright, so let's try this one. So we want to rewrite this using the distributive property. Now we have 3 terms. So when we distribute, are we just going to go to the first 2? No, we're still going to go to every single one. So here we have 5 times y squared. And we have plus 4 times 8y. And the 4 is going to get distributed to the 2. So plus 4 times 2. So simplifying, 4 times y squared is 4y squared. 4 times 8y is 32y. And then 4 times 2, 8. Can we combine any further? These both have y's in it. Right. Because that 4y squared has that square, it's not exactly the same as the y, so we can't, they can play next to each other, but we can't combine them. Depending on what the next step, if this were to turn into an equation. But as of right now, this is as far as we can go. So right now, you would just box it and move on. All right, so let's check our progress. All right, so and B is correct. Good job. All right, what about this one? Now we have 4 terms. All right, so looking at that one, without even finishing it, we know that it's going to be C. All right, example 4. So we're going to combine like terms. So this is, we need to make sure that what we're combining is exactly the same. So here we have 17a plus 21a. They're both like terms. They're both a coefficient, which is the number in front, and then the variable, which is the letter. So when we combine 17a plus 21a, they're removing the a to use distributive property, but we're going to add the numbers together, and we have 38a. Questions on that one? All right, what about this one? We have 12b squared minus 8b squared plus 6b. What are our like terms? What are the things that the variables are exactly the same? The first two. So these two are our like terms. We can combine them. Can we combine the 6b in there? No, because it's different. It's just a b, and we want to keep the b squares together. So what's 12b squared minus 8b squared? So we have 4b squared. And then we bring that 6b down, and we're done. We can't go any further because b squareds are different than b's. And so we're just going to box it and move on. Questions? All right, so looking at this one, we have 14x minus 9x. All right, are the x's, or do we have like terms? Yes, because we have 14 x's, and then we have 9 x's. So 14x minus 9x is 5x. Good. All right, what about this one? Here we have 6n squared plus 7n plus 8n. So the first thing, where are our like terms? The last two. So the 7n and 8n are our like terms, so we can combine them. So what's 7n plus 8n? 15n. Can we combine the n squared? No. So it's a. All right, so then looking at this one, so we have a word problem. Use the expression 6 times the sum of x and y increased by 4 times the difference of 5x and y. Write an algebraic expression for the verbal expression. So the first thing, what are our variables? What are they giving us as our letters?
X and Y.
X and y. What does the word, it says the expression, so are we going to have an equal sign? No, because we just have an expression, so no equal. It says 6 times. What does the word times represent? Multiply. What does the word sum mean? Plus. And what are we adding together?
X and Y.
We're adding x and y together. All right, so an increase, I heard, means plus as well. Increase by how much?
4 times. So we can multiply that. And the difference, 3 minus.
And what do we?
Y.
All right, so we've started. So we have 6 times. So 6 times what? So we're taking 6 times the sum of whatever x and y adds up to. And then increase, we're adding to that 4 times the difference. So how am I going to write 4 times?
We could go 4 parentheses, or we could go 5x plus y to the 4th power.
Well, just 4 times.
You get a 4th power.
4 times.
Yeah.
So 4 to the 4th power is it multiplied to itself 4 times, and this is like adding it 4 times. All right, so here is our expression. So let's see. So now let's simplify it. We have parentheses going on, and we have x's here and x's there. So let's distribute and combine our like terms.